welcome back to my definitive laser series. This is going to be part 5. In this part, we're going to be going over finalizing all the conditional systems that I talked about in the first few parts, mainly the stuff that handles, for instance, merging colors, splitting colors, and stuff like that. So that's what we're going to be going over today. And most of that work is going to be in the handler, in the emitter, the AC bounce, and some little change in the A laser as well. But the majority of it will be in the handler because that's where the whole system kind of merges together and controls the rest. So let's get into it. We're going to start off in our AC handler by making a lot of variables. In the previous parts, we made the invert system, the is blocking, is locked. Now we're going to add on to that. So I think first what we'll do is we'll start with the colors. So we're going to make a new category here for colors and we'll add the used color in there as well. So in category, colors for this. Now inside of colors, we're going to want a few booleans as well. So we're going to duplicate one of these. As long as it just has the instance editable, that's fine. So duplicate is blocking, and we'll call this is adjusting color. Now what this one is for is mainly to let our emitter, if we have a child emitter, know that it needs to pay attention to the color of the laser coming in, so that it can tell it for instance, merging colors or splitting colors. So that's what this is for. Now, in the case where we use this, we have our use color, which can kind of control which color we get visually. This one is mainly for if we want to talk about, for instance, splitting. Let's say we have an RGB cube. And so if we just have a normal laser hit it with no conditions, it will activate the 3 colors if we set them to override. So it will be red, green, blue. Now, if we select the adjusting color, it will need to be hit by the color white to actually make the RGB. If it's hit by blue, it will only be capable of making the blue color. So that's what this boolean controls. Now, the next one we want is more about how we calculate it, or if we really want to be precise. So this one will be called use color value. Now, in this case, if, for instance, we have a laser that is set to override the color blue, so it will only spawn a blue laser no matter what. Even if we use our merged colors, whatever, it doesn't matter. It will always be blue. If we are adjusting our color and we are not using our color value, then that means that we need to have a specific value. So if, let's say, we want to spawn a blue laser with our override, then we have to hit it with the exact same blue laser for it to work. Otherwise, it won't be capable of spawning it. Now, if this is true, though, it means as long as the color is contained within the inputted color of this object, then we can spawn that new laser. So that's what this one's for. Now, the final one we need is can merge color. And this is very much like how we use our selected color here to merge the lasers. This one is more on the conditional side. So if, for instance, we want the laser to, let's say we have 3 lasers hitting that are RGB, well, in that case, it will be considered that it is being hit by a white laser, that the color is white. So pretty much anything will be able to spawn based on the adjusting color, unless, once again, if you want to use the color value. Otherwise, it will have to be a specific laser hitting. So that's what these colors, and that's how they will handle the system. The next thing we want to add is the laser conditions. So once again, we want it to be visible here. So we're going to duplicate one of these and we will call this laser rules, we'll call it. And so we will right click to turn the boolean into an array, and we will change this array into a linear color. And so what this does, and actually we'll make a category for this, so compile twice if you get that error. And this will be, I'll call it conditions. Call this lasers. And we'll have another category for this as well. So right now, what laser rules does is it will allow us to tell our system how many lasers need to hit to activate. So if, let's say, we have a situation like this, that means that any laser that hits it will be considered. Leaving the color black means that any color is fine. But if we say, for instance, this needs to be red, then that means it needs to be hit by a red laser for it to function. And so here we can then modify that, for instance, by saying, well, if we use the color value, that means if it contains red, it works as well. So that's where these two work hand in hand. Now, the next one is another duplicate of the rules, so it's going to be identical to this. It's going to be called laser filter. And so what this one will do is the inverse of the rules. So if a color is in this filter, that means it won't be taken into consideration when talking about any of this or any of the lasers that are hitting. So it won't be part of our, it will be a part of our lasers in queue, but we're going to have another one now, which is going to be called lasers that are filtered. And so that's what we're going to make right here. So we will duplicate our lasers in queue, and we will call it filtered lasers. And so these are the final lasers that we always want to use. So if, for instance, there are no conditions, it will be identical to lasers in queue. Otherwise, it will be different. So I'm going to make a category for this. So this for linked components as well as with the lasers, and we'll call this storage. And so it's going to store our lasers in queue and our laser filtered lasers as well. So we'll make another category for these three as well, which we will, well, you know, we'll just move them into color as well, because that's exactly what they are. So they'll appear below these. So now there's just one last system we need to set up, and that is the timer. So I didn't do this, I didn't show it in the showcase, but we're also going to set up a system where if a laser hits, it will take, for instance, 5 seconds to warm up the system so that it actually opens the door after that. So that's what we're going to add now. So we can duplicate once again one of our exposed variables here. So Control D, and this one we will call reverse, this one we'll call duration, and we'll put it into a category of let's call it timer. And this needs to be a float, and we will make a duplicate of this, and this one will be called sub step. And because we're doing this with a timer, we will say, for instance, the duration will be 5 seconds. We will run the timer every sub step duration, and we will just increase the value until we reach the timer. So that way we can handle an update event dispatcher to inform exterior actors that it's moving and progressing as it goes over time. So just compile that a second time. And one thing we want to do is we want to make sure that our substep here is set to a minimum at all times of 1/60th. So just remove those for now. And we'll say 1 divided by 60, which should give 0.016. And so that just means pretty much it will run at a 60 frame per second rate at the very minimum. So you can lower this if you want so that it can go, for instance, to 120 frames. That's fine as well, but for testing sake, this is fine. So compile this, and now we need to make some local variables as well, or at least not exposed, to handle this information. So we're going to make a duplicate of our substep here, and we'll call this timer alpha. And so timer alpha will be a float as well. And we want to make sure we put our slider range back to 0 here. And we can remove the instance editable because this is going to be internal and no need for anything else. So we can actually make this private as well. So compile and set the default value to 0 because it's going to start from 0 and go to 1. Now next we need a duplicate of this as well. And this will be our, what we'll call reverse timer. Because this is a timer, we want to have a boolean. So for instance, if we have a laser that hits and then stops hitting, then we want it to reverse the timer and not reset itself. So to check which direction the timer is going, we're going to use a boolean here. So we want to change that to a boolean. So this can be kept private as well. And so we just need one final thing, and that is going to be our handle, so that if we need to invert the timer, we can cancel it immediately. So this is going to be a timer handle, and that's just what we're going to call the variable as well. And it will be of type timer handle. There we go. So compile, there we go. And that is all the main variables we'll be using now. And there will be another one that we'll be adding later, but that'll be in the next part for the external system. So with that, we can now get going. So I'm just going to move this down because we're going to need a bit of space to start things off. The first thing we want to do is to help kind of handle the whole system. We're going to make sure that both these arrays, because of how they work, when we make an array or we make a color, most of the time people tend to just go like this or control the kind of color via color wheel. But sometimes that also leaves our alpha here negative, or 0, sorry, not negative. And for instance, when we do an equal, or for instance, if we get here and say contains, it won't take into account the difference in our color here. So, or at least in the alpha. So if, for instance, you accidentally don't do that, then it's kind of annoying. So we're just going to add it here at the beginning on begin play to just make sure that all the values are set to 1 on the alpha at all times. That way we avoid any stupid mistakes that might happen later down the line. So we're going to start with a new part of the sequence. We're going to do a for each loop with our rules. We're going to plug them into the array. And what we'll do is we will say set array element. The array type, or the array target, sorry, is going to be our laser rules as well. And for the index will be our array index. Now, obviously, this is just redoing the same thing. So what we're going to do here is we're going to make a macro. So I'm going to select this by making a reroute or double clicking on the line, right click, collapse to macro, and that should make an input and an output. And we'll call this set alpha to 1. And so this will be, we're just going to change this to in and out, so it's a bit shorter. And we're going to open it up very quickly. And we're going to use this in a lot of places, so that's why we made it a macro instead of just leaving it as it is. What we do, we break this linear color, and here we make color. And so we plug this in for the R, G, and the B, but for the alpha, we'll leave it at 1. That way, if anything runs through here, it becomes 1 for the color. And so now that will happen here. We're going to copy this, paste it below, right here on completed. And once again, this just works fine. We just need to change the laser rules to be the laser filter. So right click on it to laser filter, or we can drag it laser filter and drag it on top of laser rules. So we can now compile. And so now, no matter what happens, the colors will always be set to 1 on the alpha for the rules and the filter. So now we just need to make sure that when we check our colors input from our lasers, that we do the same thing. So first thing is we're going to work on fixing our laser added. So open that up, and the first thing we're going to do is we're going to detach this. Now, as I mentioned previously, the laser in Q will stay. We're not going to change that. That's always just going to be this laser is hitting the cube, and that's just it. Nothing else. We just want to know which laser is always attached. What we do want to know is the laser filtered out? So we're going to get our new item here. We're going to say, is it double equal? I'm going to plug this into here. Now we're going to select this and collapse it to a function because we're going to be using it at other locations as well. And we'll say, call this function IsLaserFiltered. And we'll make sure this is pure, and we can just plug this in now. So if the laser is filtered, that means that we don't want to do anything with it as far as conditions go, because that means that the laser isn't actually being considered for the system. Now, on the other hand, if it isn't filtered, then we do want to do something. So the first thing we want to do is we will add it to our filtered lasers. So we're going to say add unique to the filtered lasers here. So right here, we're going to get our new item, and we will plug it in right here. Now, this can also be added right after, but we need to make a slight change to it because now there's another condition where we need to know the merged colors that isn't just which color we're using. We also need to know if we are using the merged color here. So we're going to grab that, control drag to place it in like this, like a get, and we're going to say or here. So either if we are using the color to be merged, or if we're trying to merge the colors in the condition, then we need to know the merged color at all time. So we'll just update it. So we can compile, and that will do it just fine. Now we're going to copy this, and we're going to paste it in the remove. So, because that will work the exact same way pretty much. We're just going to delete this, or actually no, we'll move it up. We will place this in. Now, once again, if it's being considered for the filter, then we want to do the same thing. If it's not considered for the filter, so it's true, we don't want to do anything. If it is considered, then we need to handle it just like we would when adding. So here we're going to say remove instead. So remove item, plug this in here. There we go. And we will just have the same system here, works fine, but we're just going to change this one to the old one because we need the negative. So just copy this and paste it right here on true. There we go. So we can get rid of these. And so now we have an updated laser add and an updated laser remove. Now, the next thing we need to do is our conditions. So previously we did the is locked, and so that we want to keep, no change there. But the next thing is, before doing all this, we want to check whether we can do all this. So we're going to move it down all the way here. Actually, before we do that, I completely forgot, but we should probably set up our IsLaserFiltered. Let's do that first. So open that up by double clicking here. And pretty much all we want to do here is we're going to use what I showed in very quickly earlier, very briefly, is we are going to say in the laser filter, does it contain what we're looking for? So that will be our A, which is our laser input here. So all the way at the bottom should be here, I believe. Get A, so just rename this because it's a bit of a mess. Laser in, we'll call it. So get laser in, and from it, we're going to get our override, our color, sorry. Well, for some reason, it's not recognizing it as a... Oh, it's because it's an object, because we did a double equal. That's my bad. So make sure this is an object. It needs to be an A laser, otherwise it doesn't work. And so now we can compile, and normally this will be incorrect. So, and I don't think we can refresh that. So we're going to right click again, say get laser in. And here we should be able to get our override color. There we go. So with our override color now, we can't just plug it in straight away because we need to make sure that it is set to alpha equal 1. So on in here, so we want to drag our set alpha to 1, plug it in, and now we have the condition we want to check for. So with that, we now have a laser filtered. We can get back to the event graph and finish this off here. So the first thing we want to do is we're going to add a branch here, and this branch is going to have a boolean, and that boolean is going to be, can we activate our laser? So we're going to add a reroute here, and we're going to select this and say, turn this into a function. So collapse the function, can activate. It's going to be pure, and there we go. So output pin works just fine here. So open that up. And this is kind of where most of the logic is going to happen. We're going to have to come back to this once we have our external stuff set up, but for now, the majority can be done just fine here. The first thing we want to do is we're going to get our filtered lasers and we're going to save them locally. So we're going to promote this to a variable, which we will call LFiltered lasers. Plug this in on activates and move this a bit to the side. We're going to put a branch, and this branch will simply look for, is this empty? Because if it's empty, that means that it cannot be activated. That means that we need to avoid it, that it's a problem. So we're going to say is empty. And so if it is empty, that means we're going to return the output pin negative, because that means that we cannot spawn it, that we cannot activate it. So if it's empty, we cannot activate it, so we just return false. Just like this. Now, on the other hand, if it is not empty, that means we do have a value. So in that case, we can do a very quick check. Are our conditions empty? If the conditions are empty, that means that we have a laser hitting. There are no specific conditions we need to meet, so we can just spawn them. Now, as far as, for instance, managing the colors go, that will be mainly inside the emitter itself. So, for instance, this will just be return node true, because there are no rules, so that means we can just keep going. That means this can be activated. Now, if this isn't true and we do have rules, we can also perform one last check very quickly that will avoid extra computation that we don't need. And that is to check whether our filtered lasers, or our local one, sorry, here, is this as long as our rules. So we're going to say length for both of these, so copy it. And if our length here, so our top one, our rules, is superior to our length of filtered lasers, then that means that there are more conditions than we can meet with the lasers. So that means that we cannot fulfill those conditions no matter what, because there are more lasers that are needed to hit than we actually have. So in that case, we want to return false, because it's not possible. We can't fulfill the conditions. So the next thing we want to check is, are we looking at merging the colors? So if that's the case, we want to get our can merge colors here. And we'll just go through that system right now. So the first thing we want to do for each loop, and we're going to go through all our conditions. So our rules here, I keep saying conditions, but it's rules. So we're going to go through our laser rules and we're going to check whether they fulfill the needs that we have. So we're going to actually make a new system here. So we're going to put this here, reroute node. We're going to select it and we're going to say collapse to function. This function is going to be called does contain color. And so what this is going to be for is it's going to check based on our use color value, is the color that we input equal to another one? So here we only have one, and this is going to be our input, we'll call it. And it's going to have a second one, which will be of the same type, so linear color, right here. And this will be the condition. And the final one is we need an output, which will be a Boolean saying whether it succeeded or failed. So this will be return value. And so this can all be turned into a pure right here. So for the input, we're not actually going to want our array element. We're going to want that to be the condition. And the input will be, is our merged color, because that's what we're looking at here, is the merged color equal to what we want here? So we will get that merged color. We'll plug it in right here. Now I believe we made a function for that. Yes, so we made get merged color. So right here. And so previously we did it this way by maxing it to 1. That works just fine. We can keep it because we already set the alpha to 1 there. So this works just fine. So we can close that. And so this get merged color will be our actual input. And so what this means is, well, is our merged color sufficient to fulfill this rule? Now, on the other hand, we do need to have another check. And that other check is much simpler, is this the color black? Because if it's the color black, we don't want to have any conditions. So we're going to make another macro for this, where we're going to say to vector. And we're going to have a second one here, and this is going to be our condition. So we're going to reroute that for now. And we're going to say, is this exactly equal? And so what this will do is check if two colors are identical, but we have to do it. The reason we're doing it this way and not by saying, for instance, break and then comparing the R, G, and B is because one, this is a bit easier to look at, and two is because if we do the break system, this needs to be a pass by value, and we can't actually use that for this. And so that will kind of annoy us later. So I'll just show you once I collapse this what I mean. So if we right click here and say collapse to macro, and we call this color equal, and we can actually make this look a bit nicer by pressing 3 equals in the compact node title, which will make it look like this. And right here, we'll just change this to just to A, sorry, and we'll call the second one B. Now, if we deselect this one here, or delete it, sorry, we get to actually select a specific color. And you can't do that if this is a pass-by reference. And the way to tell the difference between the two is if you can actually do a default value here. Now, if you can't see this, make sure you just go into here, delete these two nodes, and just recreate them by saying the plus and a linear color. And that should solve the issue. So right here, we want to check if it's equal to the color black. Now, if either of these are true, so or here, then that means that we have succeeded on fulfilling the conditions for one of these. To check if that condition worked, so to check if we finished after the loop, what we're going to need is another local variable. That local variable we can duplicate here, and we'll call L counter. And we're going to turn this into an integer and right click to make it a single variable. So we're going to say here, place it and say increment on true. What will determine whether we are completed here, whether it's true or not, we'll put a return node, is simply if our counter is equal to our length of our rules. So if these two are double equal, that means we have fulfilled the conditions and we can actually keep going. So that means this succeeded and we can activate it. Now, before we move forward, we just need to set up our does contain color here very quickly. So it's not too complicated. All we're going to do is detach that. We are going to say branch. Are we using the color value? If we are, then we need to do it slightly different. Now, we'll start with the first false because it's much easier. We're going to get our input. So get input here and look at the bottom down here. And we will say get condition as well. And we will use our triple equal to check if that works. So type in triple equal, it will get our color equal. Plug these two in, and there we go. So this means they have to be identical on the R, G, and B. Now, if this is not the case and we are using our color value, then we don't need to have it be exactly equal. What we need is we need both of these, and we need to check whether the input, so specifically the input, make sure it's in this order, break color, and we'll do it for, no, we won't use that one, use the other one, break linear color here for both of these, and we will hide the alpha because we don't need it. So copy it, paste it below. If the red color here is superior or equal to the red of the condition, and the same for all three of the colors, then that means that we have a input that allows the condition to be met. So in that case, I'm just lining, no, first we'll do the AND. So we'll AND for these three. That way we're sure that all three conditions have been met. And we can do return, sorry, no, I'll do it that way. From the true here, return node, and we will fulfill, and we will check if that condition is met right here. So this is how we check for our does contain color. So compile and save. And with that, we are done with the first part of can activate where we use the merged color. Now the next one is going to be very similar in how we set it up. So we're going to copy our for each loop here again, place it here. And once again, at the end, we're going to use the same thing as this. So for our completed, it'll be the same. So place that here. And the first thing we'll do is we will save this as a local variable just to make it more readable. So promote to local variable, L current color. Place it here. And the first thing we will check is this color black again? So we can copy this one here. I'm just invert it this time so it lines up better. So this time we'll do not Boolean and put a branch. So if this is not the case, meaning that we on true didn't get the color black, so that means we need to calculate whether we met the condition. But if it isn't, so on false, we're simply going to get our counter and we're going to increment it because that means that we have the conditions met. Now, one thing to note, just so it's clear, because it may not be evident if you don't think about it this way, but we need to remember that all of this is only ran if we have enough lasers, if we have equal or more lasers than we have rules. So that means that even if we're checking this, for instance, and let's say there are 5 rules and it says 5 lasers, well, if they're all black, it will go through here, but that still means we have 5 lasers hitting, so it's just fine. So this will work. It's not a problem. So on the other hand, on true here, we need to do another for each loop. And this time we're going to need a for each loop with break. So we're going to say for each loop with break. Now the array is going to be our local filtered laser here. And what we're going to do is we are going to get our override color. And if at any point the override color meets the conditions to fulfill the current color, then that means we'll remove it and we'll consider the counter incremented. So what we'll do is we'll say, does it contain our color? So it does contain color. Make sure this is the input and our condition is the L current color. So line these up. Now, if this condition is met, that means that it is good. That means we have a valid color for this condition. So we can move on and say this. So copy our counter here, increment it on true. And we'll also just reroute this so that we can remove it from the index. So get our filtered laser, remove index right here. And because this is a loop, we can't actually keep going here. So we want to make sure we reset the loop by breaking it immediately after removing that value. So just like that. So this is what it should look like. So we have our filtered array. We go through and check the color. If it contains the color, that means that it can be used. So we increase the counter, or it works to fulfill the condition, sorry. We can increment the counter. We make sure we don't check the same laser twice by removing it from our filtered array, which will then go through to the second rule, for instance, and check that array again. So once again, if our laser rules then the length is equal to the counter, then that means that we have fulfilled all the conditions and we can activate the system. So compile and save, and we can go back to our event graph here. On false here, so sorry, not on false, on our stop hitting, we want to do the same thing but invert. So we're going to paste this, not locked again, but this time we will say not Boolean. because in this case, we only want to do it if the conditions are not met. We want to deactivate if they're not met. And if they do change, so meaning a laser is removed, the condition is not locked, but we can keep the laser activated. So on true, it will call, for instance, if the laser needs to be deactivated. But if that's not the case, we still need to do something, because we need to make sure that if a laser stops hitting, even if the laser doesn't need to be deactivated, it may need to change its color. So for that, we're going to call here component color change that we made last time. And so we're going to plug our modified value being the input here. So we're just going to reroute it like this and move this down as well. There we go. So now we have the color that will be updated if we don't need to deactivate it. If we activate it, it will start, and so on. So now we're going to move on to our new system for our emitter, because we're going to need to make a few changes here for this to work with the new system we just set up. Because previously we made a can spawn laser, but it needs to be a bit better than what it currently is to actually work properly. We're going to keep, obviously, our does invert system. So we're going to start here with our start hitting. So the first thing is, can we hit? So we get the information that a laser just hit our object. And so that means that it has passed the check of can activate. No issue there. But what we still need to check before all of this is we still need to check, can we spawn a laser here? Because we do need to check that, because in the case where we use our is adjusting color, we want to make sure that we can spawn this specific emitter if it can actually activate. So we're going to add our branch here, and we already have the function made, so can spawn laser, and we're going to plug this in here. Now for now we haven't set that up, we just did a very basic, are there any lasers hitting? Yes, spawn, otherwise no. So here on true, we can activate our laser. Let's go here. Now we can remove this for now, it's not going to be useful anymore. And we're going to do a very simple branch. Now, this branch is simply going to check, are we adjusting the colors? So we're going to get our component here, our owning handler, and we're going to get is adjusting color. Now, if it is not adjusting color, then that means that it can be activated, because that means we've met the conditions to activate. So we can simply say, well, on false, meaning we're not adjusting colors, well, we can go through because we've made it all this way. We've already checked this condition, so we're good. We can go through. Now, on the other hand, if it is true that we are adjusting colors, we need to make a few extra checks. So we're going to start with a branch here. And what the first branch will check is our owning handler here. So we can just delete this one because we have one here. Is our owning handler using the merge? So merge, I believe we called it. So get can merge. So if it is, we need to check our contain color system as well. So owning handler, we're going to check contains contain color. It does contain color here. And what we will check is, does our merged color, so I believe we passed that through here by saying, once again with our owning handler, get merged color. So it's a function that we made. So this will be our input. Is it good enough to fulfill our override color? So we'll plug that into the condition. Now, if that is true, then we can return that value here. So we'll just say on true return, plug this in just like that. So let me just align this up, give it a bit of space. There we go. So now this will check whether our merged color fulfills the conditions that are needed. On the other hand, if we're not using the merged colors, what we want to do is we will get our filtered system, filtered lasers here, and do the same thing that we did in our normal check in the owning handler. So one thing to note is we do need to change our get filtered lasers because it's incorrect currently. It is still using lasers in queue. So select that, get filtered lasers. And it's the same type, so it shouldn't be an issue. Just plug it into the output pin and it will all work just fine. So back in our can spawn laser, we're going to do a for each loop through this and on our false. So plug this in here. If we reach the completed, we want to return false. That means that we cannot keep going. How we're going to do this is actually, I'll go through this first. So what we'll do is we will get override color for the laser that's filtered. And we will check whether this contains, once again, so we'll copy this. And we also need the override color as well. So select these three, plug it in just like this, and we'll add a branch. And so if this is the case, that means that we have fulfilled the conditions. That means that the laser, or at least one of the filtered lasers, does fulfill the condition of meeting this override color. So in that case, we want to return true. That means that we can spawn. Now, otherwise, if we reach the end of the loop, that means none of the filtered lasers meet the condition to spawn this override color, meaning that we cannot spawn it. So we can compile and save, and we can close these ones right here. So we still need to do some minor changes also for, well, actually, no, this is just fine. We keep it as it is. We set it up like that previously. And we do need to make now some changes here, because now we have a condition. So a branch here, so this is our intermediate laser change, because now if the laser color changes and all of a sudden we cannot spawn, we need to make sure that we tell it to stop spawning. So if we can spawn laser and our laser here, so our attached laser isn't valid, then we can say activate laser. So we'll say spawn laser. Activate laser here. And sorry, make sure this is on the not valid, not is valid, so it needs to be at the bottom one here. And on the other hand, here we will say remove laser, deactivate laser, sorry. Right there. So this will do the conditions for activating and deactivating our new laser. Now, we also need to do some little changes in AC bounce as well. So we're just going to make sure we do those as well. I think we can give this a try now and see how it works. So normally, if all goes well, if we click play here, it should all work the same. Normally. Clearly not. So why is that? Did I put any conditions here accidentally? I did. Yeah, so that's the reason. So this is because I accidentally did this previously, or at least, no, let me check. In our handler, did I accidentally put a condition? So I did. So that's why it's not working. So now if we play, it should, there we go. So they do bounce and they work just fine together. Now I believe previously we set the condition of the cube to be activated by last hit laser. So that's why it's hitting the red one. If I go and block this, we do have an issue. Something did go wrong here. So I think this is the issue. So as I mentioned previously, so this is in our remove laser. I said remove item here, destroy component might not work because it can sometimes cause an issue. So right here, I'm just going to clean this out and I will show you. If I play here, if we look at our output logs, there's no issue. Everything's working fine. But if I block here and we go and look at our output logs, it's going to say may not destroy component SC emitter because it's owned by something else and cannot be done this way. So it's a bug and I'm not sure why it happens here but not in the previous method, because we did the exact same thing. Nothing's really technically changed. So all we have to do to fix that is, instead of this, we are going to go into our SC emitter. We're going to create a function which will be called destroy self, and all it's going to do is say destroy component right here, compile, save, and instead of our AC bounce saying destroy component, we will say destroy self. And now it should work again without the issue appearing. Now I'm not sure why it works like this exactly, but this does solve the issue or not. Let's see if we have. So the reason here is, and this is my mistake, it's because right here we're telling it to can spawn laser, and if we are not adjusting color, we're automatically saying it's true, but that's not the case. We are not true here because we're stopping. We removed a laser from here. So it shouldn't be naturally true or false. What it should be based on is whether this one, so if we get here, can activate, this should be the condition. So this is how it should be. I thought we could skip this, but we can't. It's necessary. We do have to have this. So if we now try, we block it, disappears, hit it again, reappears, exactly like we want. So that's how it should be working. Now, right there, it goes to blue, as it should be as well. And here, the last one becomes red, so it becomes red again. If we block the blue one, it will then become blue after hitting. Now, let's set the other thing. So right here, let's test everything that we have. So first, let's go back to putting our merge color, see if that works as well. It works as well. We get magenta. Now, let's set it up to use our, no, we won't do that. What we'll do is we will delete this, and we're going to make a new actor. We're going to make a new cube, and this will be our A break cube. So what this one is going to do, just like a normal cube, but it is not going to just take a color and repeat it. It's going to break the colors into red, green, and blue. So SE emitter here, we will be calling emitter underscore red. And we're going to duplicate it, and we'll call this one blue. And we'll duplicate it again and call this one green. So for this to work, we want to make sure that our red one is, well, red. And so to do that, we'll put this to 0. This to 1, this to 0. I want to make sure we check use override. And the reason we want to check use override is otherwise it would just use the system here of use the first laser hit. If we override it, that means we're telling it, well, this is the color you always make. And all we have to do here is tell it, well, we're trying to use these conditions. So we're trying to adjust the color. So blue here needs to be blue. So this can be 0. Make sure we check use override. For the green, same thing. So 0 here, 1 here, and 0 there. And make sure we use override. Now, one thing I just noticed is we can hide these. We don't actually need them. So we'll get to that in a second. So right now we are using adjusting colors. So right here, if we are hit by red, as for instance, if we place this cube, let's grab it and put it here. Now I'm not sure where the different parts are. So, I need to move the parts first. Otherwise this isn't going to work. So break cube, let's look at it again. Red is here. Blue is also there. So we're going to move that to the side. We're going to rotate it by 90 degrees and move it to the center as well. And for the green, we'll do the same thing, but to the other side. So rotate it 90 or minus 90 this time, move it 50 and 50 again. There we go. So now we have our 3 kind of directions. So with this, normally let's just see which way they're pointing so that we don't have them going. There we go. So this should be good. If we put this here, it should be getting hit by our blue laser here, which will mean it should only spawn the blue. That's how we set it up. So let's see if this works. And it does. So we only have the blue spawning because it is adjusting color. Now, if on the other hand here we say, oh, well, we don't want it to adjust color. We just want it to do all 3. Then now, if it gets hit, it makes all 3 colors again. Now, we seem to have an issue here. I think the issue lies in the fact... We'll look inside in a second. Let's just look at this first, see if this works. So right now, we have it working with adjusting and without. So here is adjusting, works just fine. So right now, if we play, we get just blue. Now let's move it a bit forward so it also gets hit by the red. And so now it gets hit by both, so it spawns both colors just fine as well. Now, on the other hand, let's say that this, for instance, now is not going to be our typical blue. It's going to be magenta. We're going to make it a mix between blue and red. Now, if we move this back so that the red one here doesn't hit it, we won't get any color. And the reason we don't get any color is because we haven't told it to use the color value instead of just the exact input. So if we tell it to use our value here, so use color value, then it will be capable of now saying, oh, well, we're getting hit by blue and red, which makes magenta. So we can split that into blue and red. Those 2 colors can be made of this. So with that, we get what we want. Now, there's one last thing we want to check here, and that is the merging. So because merging is handled with this kind of one here. So we're going to make a new one here that's going to merge the colors. So we'll make a new cube, and we'll call this a merge. And so for this one, all we have to do in setup, we just keep our basic emitter. We don't want to use the override here, or we can, for instance, say we want it specifically to be white, specifically be magenta. And so here we will say, okay, or sorry, no, you know what? I think the best way to showcase this is we're going to say our emitter is going to be white. So we'll put it to white. There we go. And we will tell it to use override color. And what we'll do here is we will say we're adjusting color. So I'll take colors into consideration. We want to use the color value, but we're not going to say merge colors here. And so in this case, even if we get hit by, let's say we'll add a third one here. So this is We're going to change this back to its original color. I believe it was blue, if I'm not incorrect. So this will be back to blue. We're going to make another one here. Sorry, not drag the component, we'll drag the actor. So we're going to drag this here. We're going to make it come from the sky, it'll be easier. And so this one needs to be the final color we are missing. Actually, we need to move both of these a bit further. And so this needs to be emitter, and we will have it be green. Now I have to do this twice. There we go. And so now we should have 3 colors hitting it. And sorry, I completely forgot, but we didn't change our actual cube. So this is still the break cube. We want to use the merge. So right here, our merge will go out this way, and it should be white as long as it meets the conditions. And it is not getting hit by the green one, so I'm going to move it a bit further. So there we go. So now it's being hit by all 3 of the lasers, but nothing is spawning. And the reason nothing is spawning is because we haven't allowed it to consider the colors merged. Right now it's getting hit by 3 colors, but none of these 3 colors can actually fulfill the conditions to make the white. So unless it gets hit, for instance, by, if we go and change this to white, so our emitter here, put it down all the way to white, now it will work. Because it's getting specifically hit by the value that is at least needed to fulfill the conditions on one of the lasers. But if we just change this and say it can use the merge colors and turn this back to its original one, which was blue. So let's just bring that up and put it at 1 on the blue. So there we go. Now it will spawn the white anyway, because it knows that RGB makes white. So if we even remove one of these by, let's say, deleting this, it won't work anymore. It doesn't have the right colors. And so that's how this kind of merging thing works for the whole system as well. So now let's just check that little issue we encountered earlier. So I'm going to get rid of that, and we're going to put back our break cube, because for some reason it didn't seem to want to spawn things correctly. So we're not going to be adjusting color. Yeah, we'll just be using the override. There we go. So for some reason this is red, even though it should be green. Now I'm not sure why that's working okay. I think I know why. I believe the issue lies in the fact that our handler is using our first hit. Let's try merge and see the result we get instead. Yeah, so here we get yellow, which is the mix between green and yellow. So the main reason is, yeah, because our handler here, our bounce, sorry, uses the colors based on the system of our actual emitter. And so the problem with that is we're saying set color here, but the color it's actually using is incorrect. So I think what we will have to do is a very simple solution. Is in our bounce here, we're going to add use bounce color. And so what this will be, so make sure we put it instance editable, is what we're going to do is we're going to remove this from our system and just have the activate laser work. And what we'll do is we will tell it to change its current color to be equal to the color that we input. So we will say instead, if we move this a bit, branch, grab it here, and we will say use bounce color. If that is true, we will get a reference to this, say set current, I believe it's current color, not incorrect. So let's just look for it. So set override color here, and we will set that override color to be equal to the one that we just received from our input. So we will say get laser in. Let's just move this a bit. Get laser in. We will get override color, and we will plug this in right here to our override color. And here we need to make sure that we also say that this set override to true. That way it uses this specific color we just set, and we just use this. We could ignore this, but just to keep things logical, to avoid kind of any errors that might occur in the future, if for instance we make a change to how the color works here, we still want to make sure that we use the same system. So I'm just gonna do this instead. Bit of a mess, there we go. So now this should allow us to have this set up if we tell our AC bounce. So what we're gonna do is by default, I am gonna set it to true, because in most cases that is what we want. So now it should be green. There we go. So it's no longer taking into consideration what we told it to do with our handler, but because we told AC bounce to use that color, it'll always use the bounce color and nothing else. Now, on the other hand, if we uncheck that, so let's say we want this wall, oh, not that, we want this wall to use the bounce, then we can tell it to ignore it. So disconnect that, and now we have the merge between those two colors. So I believe that does it for this part. I was originally planning on doing the timer, but the part ended up lasting a lot longer than expected. So I hope you enjoyed it anyway. In the next part, we'll be doing the timer and the external system if there's enough time. Otherwise, it will be external system separate, but should be manageable all in one, I hope. We'll see you in the next part. Once again, I want to thank everybody on Patreon who has supported me. There are 2 more parts left for this whole system. And once that's done, the project files for this whole thing will be also available on the Patreon, commented with everything like usual. So thank you for watching. Hope you enjoyed, hope you learned something, and I will see you in the next part. Goodbye.